experiment, that is pH metry. Aim of the experiment is determination of buffer capacity of buffer solution. So requirements for this is pH meter, glass electrode, NaOH solution, HCl solution and buffer solution. So very first I will tell you about buffer solution. Buffer solution is a solution which resists the change in pH of the solution on addition of small quantity of acid or base or even on dilution. So you can say that any component is with you or any solution is with you, to that if you have added buffer solution, and if you are going to add a little amount of acid or little amount of base, or if you are going to add little water, that is dilution, then pH of that solution will not change. So this is our buffer solution. Buffer solution is prepared by using sodium acetate and acetic acid. So this is a sodium acetate acetic acid buffer solution. Now in this experiment, what you have to do, that I will tell you first. You have to fill burette with 0.1 molar NaOH solution. So wash it, rinse it and fill it with 0.1 normal NaOH solution. Then this is a glass electrode. Like conductivity cell, you have to wash your glass electrode 2 to 3 times with distilled water. Or simply we can say that you have to wash your glass electrode till it gives the pH value near about 7. It is 6.91, so definitely it's near about 7. Why near about 7? Because our water is neutral in nature. And pH of water, that is for neutral, the pH is 7. Hence we should get the pH value near about 7, so that we can say that our glass electrode is clean properly. Now we have to take buffer solution. So pipette out 10 cm cube of buffer solution, and to that you have to add 25 cm cube of distilled water. So already I have pipetted out 10 cm cube of buffer solution. To that I have added 25 cm cube of distilled water. Now I have to remove this distilled water and I have to dip this electrode, glass electrode, in a buffer solution. So now I am going to dip it in a buffer solution. Continuous stirring must be there. So stirrer is on, and on the display you will get some reading. So reading is 4.63. And this is a pH of our, or 6.4. This is the pH of our buffer solution. So very first, note down this pH of the buffer solution. Now as we are going to determine buffer capacity, means the ability of buffer to resist the change in pH. So for this we are going to change the pH of the buffer solution by using acid as well as by using base. So when we are going to add acid, the pH will decrease. When we are going to add base, the pH will increase. So very first, we will continue with the base. That is, from the burette, we are going to add the buffer NaOH solution to the buffer solution dropwise. And how much ml we have to add? That is my first reading or initial reading when 0 ml addition is there. At that time the pH is 4.66. I have to add NaOH solution from the burette dropwise till the pH will change to 1 unit. It will increase by 1 unit. So it must be 5.67. So see, I am going to add the solution dropwise, and you can observe the change in pH of the solution. Solution is continuously stirring, so whatever the content added, due to that the pH will change. I have to add, my initial pH is 4.66. So my final pH must be 5.6. So I have to add NaOH till my final pH is up to the 5.66. You can see the changes are there in the pH value. can see now pH is 5.3.
So slow the addition of 0.1 HCl.
So
NaOH.
0.1
NaOH, sorry, NaOH. Slow down now. Bas.
See, now pH is 5.6. So pH is increased by 1 unit and the volume required for this is 4.3. So note down this reading for NaOH required is 4.3. Now,
So
what
you
you have to?
So you can see initially your reading was 4.67 and final reading is 5.7. So that indicates how much volume has been required to increase the pH by 1 unit, and that is nothing but buffer capacity. So
now our part 1 is completed, that is we have conducted titration with NaOH. Now we have to continue with HCl. So for that again we have to wash our electrode with distilled water till it gives the pH value near about 7. So it's 6.90. We can consider it as a near about 7. Now again we have to pipette out 10 cm cube of buffer solution, new buffer solution. To that we have to add 25 cm cube of distilled water. So I have already pipetted out 10 cm cube of distilled water and 10 cm cube of buffer solution, and I have added 25 cm cube of distilled water. Now dip your electrode, glass electrode, in this buffer solution. So dip your glass electrode in a buffer solution. You will observe the change in the pH value, and it is near about same, that is 4.64. Not near about same, it's exactly same, 4.64. So now we are going to add HCl from the burette dropwise. As acid is added, so pH value will decrease. You have to add HCl till your pH value decrease by the 1 unit. So now it is 4.67. You have to add HCl till the pH value will become 3.67. So now I am going to add HCl dropwise. Stirrer must be on, and you can observe the changes in pH. See, pH value is go on decreasing. Now it's 3.89. I am adding it dropwise.
slow down the
Yes, it's 3.64. So now I have stopped the adding HCl solution. Now your reading is 6.1. So note down this reading, 6.1. Hence your experiment is over. Now I'll show you the calculations.
So with HCl your pH is decreasing from 4.6 to 3.58. So madam is going to show the calculation how to calculate the buffer capacity.
These are your readings. pH of buffer solution initial 4.64. When NaOH is added, the pH is increased by 1 unit, that is 5.64. Volume required is 4.3 cm cube. And this is your second part. Initial pH is 4.64. Final pH is 3.60 when HCl is added, that is pH is decreased by 1 unit. Volume required for HCl is 6.1 cm cube. Now you have to calculate mean volume of NaOH or HCl. So V1 NaOH, V2 HCl by 2 you will get mean volume in cm cube. Convert it into dm cube. So multiplied by 10 raised to minus 3. And finally you have to find out buffer capacity. So buffer capacity is mean volume in dm cube multiplied by normality. So we are going to use 0.1 molar. So multiplied by 0.1 divide by volume of buffer solution in dm cube. So we have pipetted out 10 cm cube of buffer solution. So volume of buffer in dm cube is 10 into 10 raised to minus 3. In this way you can find out buffer capacity of buffer solution. So that's all for your pH metry experiment.
So in this experiment you have to just define the definition, or you should know what is buffer capacity, what is acid buffer, what type of solution you have used what is pH. You have to know the definition of pH also, and the pH of acid, base and water. These are the basic questions which can be asked you in the exam, and what is a glass electrode and what it is made up of, and so on. So this was all about this experiment, that is determination of buffer capacity of acid buffer. Thank you.